Hello everyone. Today's we are going to see lecture number 7 from design analysis of an algorithm, and today's topic is big omega. As we saw in the last lecture that there are different operations of order of growth. The first one was big O, which tells us the maximum time our function, our algorithm, or our program would take to get executed completely on our systems. Today we will see big omega. Actually, big omega says how much minimum time your program or your algorithm or any instruction would take to get executed completely on the system. कम से कम टाइम कितना लगेगा आपके इस पर्टिकुलर प्रोग्राम को एग्जीक्यूट होने के लिए. दैट इज़ व्हाट बिग ओमेगा सेज. इट टेल्स अस द लीस्ट टाइम. Okay, and according to the definition we can say that f of n is equal to, this is the symbol, omega symbol, which we use in order to represent big omega. This is we can say, if say again consider two functions, say f of n and g of n, we can say that f of n is equal to the omega of g of n. It means the execution time of this function on input size is equal to the omega of the minimum time it would take with multiplied by with this function. We can say this only if this condition would get satisfied, that is f of n should be greater than or equal to constant times g of n. If we will take a constant and we will multiply that constant with this function, okay, the execution time of this must be lesser than this. Okay, it should not be greater in this case, and this should be greater than this or equal to this, not lesser than this, which means the execution time of this function should be greater than this function but should not be lesser than this. Okay, that is what big omega says. So we can also say the growth rate of this function f of n should be or will be always greater than the growth rate of g of n. Okay, if you understood the last lecture, this is easy to understand. Again, let's take an example. Let f of n be equal to 3n plus 2 and g of n be equal to omega of n. Okay, so we have to prove whether this 3 of n plus 2 is equal to omega of n, and in order to prove this we have to check the condition that f of n should be greater than or equal to g of n, some constant multiplied by. That means we have to check 3 of n plus 2 must be greater than or equal to constant times n, this n, isn't it? So let us assume, let n be equal to 1 and constant be equal to 1. We will take only one input size and let the constant be equal to n. 3 into 1 plus 2 is greater than or equal to 1 into 1. This is 3 is 5 is greater than or equal to 1. Yes, it is true. That means keeping the constant equal to 1 and increasing the input size, this condition will get always satisfied. Let us take one more example. Let us increase the input size. Let n be equal to 50. So this is 3 into 50 plus 2 is greater than or equal to 1 into 50. This is 50. This is 152 greater than or equal to 50. Again we did it. So that is what it says. If this condition will get satisfied, now in this case this condition gets satisfied when we took n is equal to 1 and we kept the constant equal to 1, or this function will get satisfied. We can say that f of n is equal to omega of g of n for this particular function. So in short, big omega only says how much minimum time your algorithm will take in order to get executed. Okay, this is about big omega. Now the last one is big theta. Big theta basically tells us what is the average time your algorithm or your program would take in order to get executed completely. That means we can say big theta is a combination of big omega and big O, right? Like in this case, this function should be greater than this but should be less than this. उर्दू में जब हम बोलते हैं ना, अच्छा, इफ़ आई वुड गिव यू एन एग्जांपल, मैं बताती हूँ आप लोगों को कि ये आपका असाइनमेंट है, मुझे बताओ कम से कम टाइम में कितना टाइम लगेगा आपको एक एग्जीक्यूट करने के लिए. व्हेन आई एम सेइंग कम से कम, दिस टर्मिनोलॉजी सेज बिग ओमेगा because omega says us the minimum time it would required. If on the same example I would change my terminology, I would say ज़्यादा से ज़्यादा कितना टाइम लगेगा आप लोगों को ये असाइनमेंट कंप्लीट करने के लिए, व्हाट वुड यू से? द मैक्सिमम टाइम योर एल्गोरिथम विल टेक, दैट इज़ योर बिग ओ. व्हेन आई एम सेइंग अच्छा एवरेज में मुझे बताओ कितना टाइम लगेगा असाइनमेंट कंप्लीट करने में, दैट मीन्स इट इज़ द एवरेज ऑफ दीज टू. द मिनिमम टाइम प्लस द मैक्सिमम टाइम विल गिव यू द एवरेज time, and that is what big theta is all about. It tells us the average time taken an algorithm to complete its execution. Okay, so we say that this function, and it is represented with this theta, is equal to theta of g of n only if constant 1 times g of n should be less than or equal to f of n, and this f of n should be less than or equal to constant 2 times g of n, isn't it? By this it means f of n should be greater than or equal to constant 1 times g of n, and by this it means f of n should be less than or equal to constant 2 times g of n. Okay, so we can say the growth rate of this function, therefore we can say the growth rate of the function f of n will lie between the growth rate of the constant g of n function. Always remember, here I wrote constant 1 times g of n, here I wrote constant 2 times g of n. It means that these constants may vary. If for this I will take constant 1 is equal to 1, it's not necessary I have to take the same constant for this. I can change the constant. I have to see on what constant I should take so that my conditions will get satisfied. So again we will take an example and we will understand this. Take the same example, 3n plus 2 is equal to theta of n. So that means for this you have to check both, that f of n should be greater than or equal to constant 1 times g of n, okay, and you have to check this f of n should be less than constant 2 times n. Okay, now see for example, let n is equal to 2 and constant is equal to 3. Okay, see whether this can you can do this. Take n is equal to 2 and take constant equal to 5 and see if this gets satisfied or not. If yes, then you can say that f of n is equal to theta of g of n. Thank you.